In this video, I'm going to be talking to you about nominal and effective interest rates. When interest rates, compound interest rates, are quoted with different compounding periods, it's often difficult to tell exactly which investment or loan will be the best for the customer. As an example, if we wanted to compare an investment at 6% compounded daily versus an investment at 6.5% compounded quarterly, it might be difficult to immediately tell which investment is the best one. But what we can do is calculate what the effective interest rate would be. That is, what the interest rate would be to achieve the same payout if we were using simple interest over the course of 1 year. So in order to do that, there's two options. We can just calculate what the final amount is on specific investments under these two scenarios and compare them, or we can calculate what's called the effective interest rate. Now there's a formula for the effective interest rate that it's worth remembering. And that is E is equal to 1 plus I over K to the power of K minus 1. So let's calculate the effective interest rate for both of our two scenarios in our example here. So let's call this A, and let's call this B. So the effective interest rate for A will be 1 plus I over K to the power of K minus 1. So that will be 1 plus the interest rate as a decimal, 0.06, the number of rests per year. So it's compounded daily. That will be 365 to the power of 365 minus 1. So when we pop that in our calculator, again we must do that exactly as it appears on our page. So it will be 1 plus 0.06 over 365 to the power of 365. Whoops. I'll just start that again. 1 plus 0.06 over 365 to the power, so I'm going to press shift and then my third key here. No, that's not what I want. 1 plus 0.06 over 365, and we don't want the shift button this time, we just want the index button to the power of 365. Now I'm going to move my cursor forwards, minus 1, and I get 0.0618. So that is 6.18%. If I do the same thing with my second scenario, 6.5% compounded quarterly, so I'll use my equation. E is equal to 1 plus I over k to the power of k minus 1. Substitute in my values. 0.065 over 4, because the second scenario, B here, the rest period is every 3 months, quarterly, so there's 4 quarters in a year, to the power of 4 minus 1. If we do that now in our calculator, we'll get 1 plus 0.65 over 4 close brackets to the power of 4 minus 1. And we get 0.0666, which is 6.66%. So we can now compare the effective interest rate for the two scenarios, and we can see that scenario B is actually a higher interest rate than scenario A. So if this was a loan, obviously the higher interest rate would mean we'd be paying more. If it was an investment, the higher interest rate would mean that we get paid more. So depending on whether it's a loan or an investment, you can decide which one will actually be the best one. And that's effective interest rate.